Okay, great. So let me start this presentation with an overview of what I'm going to discuss. But first, I just want to mention that this talk is from a chapter in a book on artificial intelligence from Springer Press, published a couple of years ago by a group of Czech scientists who had a grant from either the EU or from the Czech government. And it was a big grant. They produced 2 books out of the research. I was included on it. And this book, both of the books have the same title, except what comes after the colon is different. So both of them are called Beyond Artificial Intelligence, but this one is colon, the disappearing human-machine divide. So this is from that chapter. So first, an overview of what I'm going to discuss. The growing body of work in the new field of affective robotics involves both theoretical and practical ways to instill, or at least imitate, and this, people have talked about this before today, is imitation versus real installation of emotions in AI. So the other thing about affective robotics isn't to just instill emotions into AI, but to instill emotions toward AI into humans, to make, in other words, a connection between human and AI that's an emotional connection both ways. So the aim of this whole project is to guarantee that as AI becomes smarter and more powerful, it will remain obedient, safe, and attractive to humans. That's the hope. Inducing emotions is important to this effort to create safer and more attractive AI, because it's hoped that by those doing it, that instantiation of emotions will eventually lead to robots that have moral and ethical codes built into them. And that'll make them safer. And also, the hope is that humans in AI will be able to develop mutual emotional attachments, facilitating the use of AGI-based robots, artificial general intelligence, as human companions as young people decline and old people get more numerous. So this paper, or this presentation, discusses some of the more significant of these recent efforts, and I'm going to address some important ethical questions that arise relative to these efforts. So there are several motives for trying to create emotions in artificial intelligence, according to the people who want to do it. The first one is safety. If AI continues to become more intelligent and is eventually able to act autonomously at the same level as a human, this is going to be important. And this is especially a focus in the service robot industry, because a big sector of what are called service robots are military. And we don't want those to be too dangerous, or we end up with something like the Terminator. So the growing body of work in this new field seeks practical ways to instill, or at least imitate, human emotion in robots. Ronald Arkin at Georgia Tech and Otto Rossler, German philosopher, they have software architectures they've invented that are examples of projects along these lines. And I'm going to talk about those a little bit. So they attempt to build into artificial intelligence the feelings of guilt and remorse, or benevolence and bonding, respectively. So Arkin talks about guilt and remorse and tries to build that in with algorithms. And Otto Rossler talks about benevolence and bonding as a way toward positive emotional AI. Ronald Arkin's project, you see his book on the screen here, is funded by the United States Department of Defense, or was, and described in his book, Governing Lethal Behavior in Autonomous Robots. His project was to develop an artificial conscience for smart, completely autonomous weapons for the United States military. Arkin developed the architecture of this conscience, or ethical governor, as he called it, based on coded reasoning and built on an ethical system that most closely approximates Kantian deontology. That is, a philosophy that's focused on a sense of duty, but Arkin used codified laws of war as a basis for the deontology. In addition to the rational decision tree included in deontology of if-then statements, which makes algorithmizing easier, he says that there should also probably be some sort of ethical adapter built in that's based on artificial affective function, that is, guilt, remorse, and grief. And that would motivate a weaponized AI to review and correct any mistakes it had made in the use of lethal force. This would be done especially by focusing on guilt. The coding that would induce guilt would be the robot's own monitoring of certain measurable parameters like non-combatant casualties and damage to civilian property, among others, or, on the other hand, by criticism from human monitors of the weapon. Formally, this affective function would be expressed like this. That's the algorithm for it on the screen, where V guilt represents the current scalar value of the affective state of guilt, and max guilt is a threshold constant. So now if that threshold constant of max guilt is exceeded, then ethics have been breached and the weapon is automatically disabled. The biggest problem with this idea is that such affective functioning only occurs after some kind of horrible humanitarian violation has already occurred. The other problem that I see is that these robot emotions are only vague simulations, or not even that, but just diagnostic troubleshooting, as done now with malfunctioning computers, but under a different name. They're still based on cold calculation, based on assessment criteria, not on empathy or sympathy, or, as Arkin himself admits, compassion. So calling it affective computing is not really accurate. Let's turn to Otto Rosler now. The German physicist and complexity theorist Otto Rosler's ideas are laid out in a number of articles, but the most important one is his 2004 article at the top of the screen called Nonlinear Dynamics, Artificial Cognition, and Galactic Export, which is the top one. By way of Rosler's own mathematical models regarding what he calls spatial Darwinism, which I don't have time to describe here, bonding would be programmed into a machine. That is, algorithms would command the machine's autonomous path optimization, his term, which Rosler sees as analogous to human emotion in the way that it works. So programming a machine to stay in close proximity to a human is thus relatively straightforward. But bonding demands that the same human be seen as integral to the machine's survival and valuable in its own right. This is what Konrad Lorenz called the animal with home valence. So these algorithms would be set to identify a particular human as the animal with home valence. In other words, the mother for most animals. You see Konrad Lorenz here with one of his pet ducks. So the machine would become automatically socially bonded to that human upon first viewing him or her, just as animals bond with the mother figure by first viewing the mother figure after, say, a chick hatches. As I've said elsewhere, the main philosophical problem here is that this theoretical architecture collapses the difference between emotional bonding and simple proximity to another being. So, in addition to these efforts to build emotions into artificial intelligence, equal effort has also gone into inducing emotions toward robots in humans, as with experiments at MIT Media Lab first made famous by Cynthia Brazil, and experiments by Japanese roboticist Hiroshi Ishiguro with his humanoid therapy robots. I got a chance to talk to Ishiguro and deal intimately with his robots, and it's really kind of spooky, honestly. It wasn't emotional bonding there for me at all. The chief aim has been made to make increasingly common domestic and personal robots attractive to consumers and safe for them to use. So, affective robotics is gaining steam rapidly due to these needs for friendly and safe AI. Empathy is what most scientists see as the basis for friendly AI and good social interaction between robots and humans. So a lot of the research being done to improve human-robot interaction is mainly in the area of generating empathy in robots and creating empathy toward robots in humans. So let me illustrate this with one recent example. Empathy is what, a few years back, a group of researchers funded by the European Union's Platform 7 agency used empathic robots, you see one on the screen here, as teaching tools for elementary school students, and they were teaching them how to play chess. As the researchers said, and I'm quoting here, the goal of their project was not to build robot companions that replace human contact, but rather to design companions that fulfill their tasks and interact with human contact, but they want to fulfill their tasks and interact with people in a socially and emotionally acceptable manner. So in one of their experiments, reported in a recent article, they used an empathic robot called the iCat to teach students to play chess, as I said. When the student had trouble learning chess from the robot cat, the robot would use one of 4 empathic responses. It would either encourage comments, give encouraging comments to the student, or it would offer them help making a move, or it would make a bad move on purpose so the student would have a leg up in the chess game, or finally it would use scaffolding, which is the most commonly acceptable teaching technique, which means that the robot would provide feedback on the last move, and if the move was bad, it would let the user play again after the feedback. By the way, the ability to read human facial expressions here was designed into the robot. It had 6 different facial expressions, I'll show you in a minute, that were considered to be empathic, you know. So the whole idea was to allow the students to develop a bond because the cat would have facial expressions to help its responses. And by the way, this iCat and its facial expressions were then used later for therapizing people on the autism spectrum to get them to recognize nonverbal facial cues. So, how successful has all this been? Well, not too successful. Concerning robot emotions, of the type Arkin and Rossler want to achieve, AI is not powerful enough yet to support this complex function of sentience. So how about empathy? Do robots actually feel empathy? Did that algorithmizing work? Well, no. As of now, they can only simulate the physical markers of empathy. So you can see this in the 6 basic emotional faces used to simulate empathy here on the screen in the iCat. But efforts to create the appearance of empathy in robots, the physical markers, have been pretty successful with humans. and consequently inducing empathy in humans toward robots has met with success. Studies show that humans develop real attachment and empathy toward robots. Human empathy toward and attachment to robots is discussed by Matthias Scheutz in his chapter in a book called Robot Ethics. He gives a lot of examples of this gleaned from various studies. One that's somewhat surprising to me anyway is the fact that many people form emotional attachments with their robotic vacuum cleaners, like the Roomba you see on screen here. Now, these are simple devices that merely clean your floors, but you program them for the time you want them to run, and they basically run in a grid-like pattern until they calculate that they've covered the whole grid. And they bump into things and so forth, and then they dock themselves. But despite that simplicity, many people personify them and even form a sense of such gratitude toward these robots that they give the robots a day off and clean the floor themselves to give the robots a rest. Now, you and I, we know that robots don't need a rest. They don't have emotions, but humans ascribe emotions to them and even put costumes on the robots and empathize with them by dressing in costumes that include the robots. This is one of the costumes that Scheutz shows that humans have dressed the robots in. Now, especially concerning to Scheutz about all this is the possibly dangerous behavior that such attachment causes. Scheutz chiefly worries that such one-way attachments will make humans emotionally vulnerable to manipulation by robots and AI via their human corporate makers especially. So the example he gives is you buy a robot, you cathect on it, you have emotions toward it, and then the corporation that made it knows that. So they program it so that 2 months after owning it, say, or 3 months, it starts suggesting to you to buy another product from the company. And you're open and vulnerable to that because of your emotional attachment. But he also talks about more concerning aspects of this kind of behavior. He talks about soldiers' attachment to their bomb disposal robots in recent armed conflicts. Now, in these cases, it's not just a matter of wanting to give the robot a day off or to dress it up because you're emotionally attached to it. Personifying a bomb disposal robot makes soldiers reluctant to trade them in for new ones once they've become too damaged to function properly, because they're attached to those particular robots. So they keep using it even though it doesn't function well, and that can kill them. All right, so these ethical concerns of Scheutz's and those of mine that I've discussed to this point are specific to particular experiments or projects. What about the ethics and philosophical dimensions of the larger project of generating emotions between humans and AI? Well, first, although the big problem for more advanced types of projects like Rossler's and Arkin's is our currently insufficient engineering capabilities, there's also a larger philosophical problem. And that is our perennial disagreement. Now, we were talking about this in the back just before I started talking. Our disagreement as to what cultural basis we should use to define proper ethics. When we discuss and define values like benevolence or conscience, especially given different cultural viewpoints, like Kantian deontology, which is a Western system based on pure duty or rule-based ethics, or Buddhism, based on selfless compassion, or utilitarianism, which is based on the greater good of the many. Now, utilitarianism and Kantian deontology are favorites of programmers because they line up really well with making algorithms. They're if-then types of philosophical systems. But those are both Western systems. Buddhism is not a Western system, and in some senses, it disagrees with some of the premises of the Western systems. I'll talk about it in a second, a little bit deeper. So second, If inducing emotions in AI is important to the effort to create friendly AI, because it's hoped that AI and humans will develop mutual emotional attachments, then the current experiments are working badly, because so far the emotional attachment has been one way, that is, humans to robots and AI. As Scheutz reminds us, and this is potentially problematic for the reasons noted regarding human vulnerability to emotional manipulation by AI. And third, there are the potential philosophical problems we may create for our treatment of a new species if we manage to create a sentient form of AI. So if it's sentient and it feels and has emotions, the problems in this scenario are numerous, but the chief one is regarding emotions is this. As James Hughes points out, he's a sociologist and a Buddhist monk. In order to feel emotions like guilt, compassion, and empathy, we would have to create suffering beings, because only by suffering do we learn how to understand others' pain. But creating a suffering being is of dubious morality. So would these requirements for instilling compassion in an AI be inhumane? Buddhism says it would. He notes this in an article, a recent article. So research on effective robotics raises some other important philosophical questions relative to it, as well as to human progress in the digital age. Do efforts such as the ones I have outlined risk reducing the complexities of emotive human movement and the nonverbal spectrum to patterns of imitation and functionality? And I'm winding up here. Clearly they do now, it's just imitation, but could these theories and programs do more? Maybe. Anyone who reads the literature can see that the intent of scientists and others involved in this project is clearly to do more than reduce human emotion to mere imitations and functions. But there's no way yet to do that, and they see imitation as an important initial step on that road. So does the increasing, I'm going to conclude by saying this, does the increasing juxtaposition of the human with the digital undermine human kinesthetic communication processes? Right now, yes, but in the future, the answer to this depends on what sort of perspective one takes on the long-term goals of AI research and robotics. From researchers' perspective, they're trying to replicate those same communication processes and in all of their spontaneity and reality, because their ultimate goal is to create robots and AI that are humanoid and, importantly, are emergent, that can, in other words, evolve. If that occurs, then maybe new hybrid AI-human kinesthetic processes will evolve as well. And that sort of spontaneous random change is part of the process of emergence. But that future of sentient, emergent, artificial beings is a big if at this point, and from what most scientists say, still a long way off. And it may have the ability to feel guilt and remorse, but is that humane and moral? That's what the question I want to end with. And that may be something we want to discuss here and in future research. Thank you very much.
Thank you very much, Kevin, for your thought-provoking talk. We'll take one question from the audience, if there are any, for Kevin.
This was very interesting, thank you. I have one question. Is it about, did someone try to implement Immanuel Kant's ethics into AI system, can I say? And what do you think about that?
Sorry, say that again, I couldn't.
Did someone try to implement Immanuel Kant ethics codex into AI system?
Yes.
Yes.
Ronald Arkin tried using that. In fact, the algorithm I put up there is part of his process of algorithmizing Kantian deontology. He chose to use that because he thought it was a little bit more worked out than utilitarianism for his purposes. He writes, by the way, if you want to see those algorithms, they're in his book. Spoiler alert, he ultimately admits failure because he's instrumentalizing emotions which he just couldn't do. at this point. So your other question was, what do I think about it? I agree with him. I think it's too early and kind of a fool's errand to try to algorithmize emotions. Emotions are too complex. One thing, you know, when we make moral decisions, we don't just use logic, and he was trying to just use logic. You know, we use sympathy, we use empathy, compassion. That stuff you can't make into algorithms yet.
Thank you very much. I'm looking forward to continuing this discussion in the open session.